Good afternoon. My name is Zanella, and I am actually a colleague of Denis. And I would like to talk to you about one of those philosophical questions we have sometimes as iOS developers, which is, when did my view layout? Because, it's kind of magical, right? Anytime you change a constraint, could be after a touch or after an HTTP request, UIKit defers the layout computation time, and the goal is actually clear, simple. It's to reduce the number of layout computation. So if you change multiple constraints, the layout will be done only once. But even if the goal is clear, sometimes, at first, it can be very confusing. Like this question we all faced at least once. Why does changing a constraints inside an animation block does not animate the change? And even if you understand the concept, sometimes this delay is hidden. Like in all those questions, like when does a collection view or table view finish reloading its data? So maybe if I could understand how does UIKit manage to defer the layout computation time, I could answer to all those questions and finally fulfill my dream, winning as many points as Rob on Stack Overflow. So, how can UIKit defer the layout computation time? Well, let's take a very, very simple example. One button, one constraint, and one breakpoint in one of the methods involved during a layout pass. Something like view.did_layout subviews. And you will get something like this. And I think that we can already remove the top our stack because it's obviously UIKit beginning its layout phase. And let's focus our attention to the bottom of the stack, the origin. Where does this method come from? We visibly have two parts, so let's start with the first one, the main function. What's the main function? Well, like any other Swift program, an iOS app starts with a main function located in a main file. And it's actually the entry point of the main thread. So once this method exits, the process is killed. And it's what you want, like in this very simple command-like tool. But what about the main function of an app? It's a long life process. Well, actually, it's just a call to a function named UI application main. And UI application main won't exit until it decides to do so. So a very first silly implementation of this could look like this, where we will use just an infinite while loop, which will keep asking the system about an event. And of course, we all see the problem here. We will get very, very bad performances because most of its lifetime, the thread would do an unnecessary work. And we will probably burn our CPU. Of course, the solution is in the second part of the stack. And it's obviously related to a concept called a run loop. So what's a run loop? Well, a run loop does exactly what we are looking for. It keeps a thread busy only if needed. And to do so, it mainly does two things. First, rather than pooling, it waits for an event and puts the thread to sleep when doing so. And secondly, it dispatches the event to its receiver, waking up the thread. So what's our run loops event in an iOS app? Well, it can be a lot of things, but let's consider that it's just system events. Things like touches, touch, keyboard input, screen locking, things like that, and Apple call it sources. So let's see a run loop in action. Here, yes, we have a thread, and let's add a run loop to it in order to manage it. We can attach any arbitrary block of code we want to it, and associate them to an event. Most of this lifetime, in general, a thread does nothing, and the run loop is just waiting. Whenever an event arrives, the run loop wakes up the thread and executes the code associated to it. When it's done, the run loop puts the thread back to sleep. And you can attach as many events as you want to it. You can monitor as many events as you want. Another cool thing about run loop is that you can also attach observer to it. An observer is also a block of code, but this time it will fire at special locations during the execution of the run loop itself. So you can be notified when the thread is put back to sleep, or when the thread just wakes up. And anytime a block of code is executed, it will always derive from one of those methods with a useful name. It helps you to understand where you are in the run loop. And if we go back to our initial stack, we can see that viewDid layout subviews actually derives from an observer callback, and our button action derives from a source. So I think that we can go back to our main function and to have a better understanding of those two stacks, let's try to implement a really simplified version of it. Of course, this is all fake, right? I don't want to receive a letter of complaint or things like this. So, of course, it starts with a run loop setup, and because we want to proceed touches, we add touch. So anytime a touch arrives, we'll have a callback, and this is where UIKit could execute things like starting a responder chain. And because we always want to have the last word anytime something is executed on the run loop, we add an observer to be notified at the very end of the run loop second of event, to gather all the view changes and perform the final processing. And this is where UIKit could perform the layout. Let's see this code in action. Here, our button is currently on screen. Because nothing is happening, the thread is just sleeping. When a touch arrives, the run loop wakes up the thread and schedules the touch callback. And this is where our touch button action could be called. The run loop continues, and right before going back to sleep, we will get a callback on our observer. So when did my view layout? Well, in this very, very particular case, visibly, it was after a touch source waked up the main thread to run some code, and right before the thread goes back to sleep. Well, is it always true? I mean, is it that simple? A layout is derived from an observer callback? Of course not. And sometimes you will see something like this. So visibly, for some internal reasons, UIKit will perform the layout right in the source callback. But does it really matter? Of course not. We should not rely on such implementation detail. And I think that for most of those Stack Overflow questions could be actually answered in 3 simple points. First, be aware of the layout process. Respect this 2-step cycle, validation, computation, and be aware of the gap that could exist between them. And always try to understand where you are. Should I validate things or compute things? Secondly, only rely on UIKit events. When you're doing a dispatch async or things like that, you're actually creating an unnecessary run loop. and there is absolutely no guarantees that it would work. And actually mapping weird run loop events to meaningful method with a meaningful callback, it's actually already the job of UI-Kit. So rely on it. And finally, if you really need to get a callback, you can force the layout to kind of disable this optimization made by UI-Kit. And only if you're sure that nothing will modify the same layout again in the same callback. Thank you.
Thank you, Gaëtan. So, you didn't say that if you actually managed to get to those 3,000
No, I didn't.
points?
No, I didn't.
No? And did you raise, at least?
Yeah, I got, 3,000 points.
Oh, that's not bad, not bad.
So, what actually did motivate you to dig deeper into this? Because there's lots of stuff to dig, I guess.
Well, I oriented the talk on this layout process, but what I really wanted to know was what an iOS app actually is. And I think that at the end, we can get, we have an idea, which a run loop, an iOS app is just a main function running a run loop on the main thread.
And super simple, actually.
Yeah, and it's also interesting to actually create something to learn and to make sure that you understand properly. Did you do that during the business hours, or did you do that as a side project? And
well, both.
Yeah.
Yeah, I code every day. And
and so, how can you use this knowledge to your everyday life as a developer?
Well. Well, it helped me to have a new point of view on the iOS app. All this incessant callback. Where do they come from? And it's also helped me to not be afraid of the bottom of the stack when you use a breakpoint.
Yeah, that's very nice, because I guess not many of us can understand what actually happens when you print all the stack. There's lots of stuff which is actually like dark magic to many of us.
Yeah, and usually I was talking about business hours, because usually when you have a problem, you go to the Stack Overflow, or you try to find the answer, and once you have the answer, you quickly move to another subject, and you don't really go and you don't really dig. And that's really interesting to see that sometimes digging is really worthwhile.
Yeah, and speaking about business hours, I mean, it's the only thing we actually care about. Was it easy to find all this info?
Well, it wasn't. It actually took me several months to gather all this info. And I think the reason is that Apple doesn't want us to think about this detail, and they are right. Mm-hmm. They want us to reside in this kind of distorted reality where you have a method with view did appear. Who knows what did appear actually mean? We are engineers. We are not painters.
Okay, thank you very much for this talk.
Thank you very much.
Thank you.